This was page 31. We started it. I believe it's 31, right? Okay. We started it, and I said we're not going to cover the whole paper in one day. We're coming back to it because the rest of the stuff on the paper is coming up today. So if you'll look down towards the bottom of it, this is a quick reminder of slope. We're not really working with slope today, but I just want to make sure you do remember what slope means, what's it look like, what are the 4 different cases, types of slope, and then it's going to lead us to the back, which is what we are absolutely using today. So if you recall, slope is referring to a rate of change, meaning it's measuring the spacing or the distance or the movement. There we go. It's measuring the movement up or down along with the movement right or left of a line. So it's the steepness of a line, right? If a slope is positive, then it has a position like this right here, where it's starting bottom left and it's going towards the top right. So this line here has a positive slope, because as I go up to reach the next point, I go right. Those are both positive numbers. Up is positive, right is positive. This line here has a negative slope because as I start from the left, top left corner, as I go down, which is negative, then I go right, which is positive. What's a negative divided by a positive? Negative divided by a positive is what? A negative. So this has a negative slope. Another way to remember that this has a negative slope, I don't know if anyone's ever shown you this, but you can take a line with a negative slope and you can turn it into a capital N for negative. The line will replace the middle bar in a capital N. You cannot do that with a line that has a positive slope, okay? So that's a little trick to recognizing really quickly, oh yeah, that's a negative slope because I could definitely make that the bar in a capital N. Can't do that with a positive slope. Then you have 2 specific special case scenarios. These are called special cases, meaning they don't happen a lot, but they do happen sometimes. When you have a 0 slope, it means that the line is laying down in a horizontal manner. So this has a 0 slope. When you have an undefined slope, it means the line is strictly vertical, up and down. Not slanted in the slightest way, not slanted at all, because then that would lean, once it starts slanting, now it's either positive or negative. But if it's straight up and down, it's undefined slope. How do you remember this? Well, one way is to think of a car, or think of a person walking, if you will. If a person was trying to just walk a horizontal line, it doesn't take a lot of energy, right? It's just flat. As I'm walking up here back and forth, left and right, I'm not requiring a lot of energy. Now, if I had a vertical that I needed to walk, can I do it? No. And don't say, well, what if you were rappelling? Well, yeah, that requires equipment. So we're saying if I just was to straight up walk up that wall, can I do it? Absolutely not. So you think to yourself, can a person scale a wall? And the answer is no. So it's undefined slope. So 0 slope, 0 energy, not a problem. And then undefined slope can't happen. Not going to happen. I am not scaling a wall that is strictly vertical, right? You with me? Okay. Go to the back. On the back, here's where you need a highlighter. I'm going to teach you an acronym that is going to help you with today's transformation, okay? The acronym is HOY Bucks. You have to be very careful when you say it. Please don't accidentally mess up you say bucks. Don't get what y'all are high school. You know what I'm talking about. Hoy bucks. It's an acronym, meaning the letters come from the first letter of words to help you memorize what they stand for. Why am I teaching this to you? Because I have found in the past that kids confuse vertical and horizontal lines and their equations and their slopes. They confuse them. So enter Hoy bucks to help us remember which one's which. So, what does horizontal, or what does Hoy stand for? It stands for horizontal lines have a zero slope, meaning M is 0. If you recall, M stands for slope. And the equation of the line is y equals the y-intercept. Do you remember what y-intercept means? It's kind of like the definition's in the name. Y-intercept. Axis. Very good. Y-intercept is where a line crosses the y-axis. So the equation of the line, I'm putting EQ, the equation of a horizontal line is always y equals, and then it's a number, and the number is where it's crossing the y-axis. So watch this. There's 3 ways to read it over here, 3 examples. You have the equation, y equals 4. That is an equation of the line. Looks like I'm just telling you, hey y'all, y is 4. But it's actual, like that's an equation of a line. I could go graph that. If I did graph it, I would I'd recognize, watch how I do this. People get confused because it's so simple, short, and sweet. The thought process is less than 2 seconds. And so they're like, what did you just do? So watch. I'm pointing to y equals 4. I would see that and I think to myself, that looks weird. That's one of those lines that's either vertical or horizontal. Enter Hoy bucks. How do you spell Hoy bucks? Which one has a Y? Somebody say Hoy. Hoy has a Y. So this would tell me Hoy would help me here. Hoy is H-O-Y. H stands for I'm going to draw a horizontal line on the y-axis at what number? 4. I'm going to go to the y-axis. I'm going to find 4. That was too much. I'm going to find 4, and then I'm going to draw a horizontal line. That's how fast we're graphing these lines. Now, what would it look like as a t-table? Well, it would be very uninteresting because the entire y portion would be the number 4. Hence the reason the equation is y equals 4. Meaning it doesn't matter what x is because y is 4. Now, it comes from the fact that in the slope would be 0, which means you've got some horizontal movement, but you have no vertical movement. So you have 0 divided by a number, which is 0. All right, what about bucks? Bucks stands for vertical lines, have an undefined slope, meaning there is not one. There's a difference in the number 0 and undefined. 0 is a number. It's a value. I can point at it on the number line. Undefined means does not exist. Okay? And then the equation, EQ, the equation of a vertical line is always x equals the x-intercept. X equals the x-intercept. So if you come over here to our examples, here is an equation of a line, x equals -2. If I was to graph this, I would look at it and say to myself, okay, that looks weird. It looks like it's just telling me x is -2. This is an equation of the line. I would think Hoy bucks. Which one has an x in it? In Hoy bucks, which one has an x? Vux has an X. You would think to yourself, Vux, V for vertical. I'm going to drop a vertical on the x-axis at what number? -2. So I'd go to the x-axis, I'd find -2, and I would drop a vertical. And there's my line. If I looked at the T-chart, it would be uninteresting because all the x values would be -2. Now, the reason I show you this is because we are practicing reflecting over random horizontal and vertical lines. What was that?
That was probably Coach Gray's.
Oh. We're practicing reflecting over random horizontal and vertical lines. On Thursday, I was going to say Friday, but Thursday, we reflected over the x and the y axis, right? Remember that? Okay, do the x and y axis ever move? Are they in the same spot every problem? Yes. We're doing random horizontal and vertical lines that move, which means you have to plot them correctly before you can reflect. Does that make sense? And then the reflection process is the same. So the hardest part of this is graphing the line correctly. If you graph the line wrong, you're going to reflect wrong. All right? So now that we have finished with the basics, you might want to keep this out. I'm going to close the screen on it, but you might want to keep it out. Shift your attention to your transformations book. Go to your transformations book. And now what I want you to do is open up the booklet. This was when we reflected over the x-axis. This is when we reflected over the y-axis. Now we're going to go here. We're reflecting now over a horizontal line. Then we're going to reflect over a vertical line. Now, I've already graphed the lines for you on here. We are going to practice graphing them ourselves, but the first two I wanted to graph them for you. But let's just pretend like they're not even graphed. Let's just look at it this way. It says, reflect over a horizontal line. Okay? Horizontal line, if you will, you do have some space at the bottom of your page. I would love for you to come down there and to write this. Hoy. And then you could either, since this is horizontal, you could write hoy on this one, and you could write bucks. If you want, we could separate it. You can come over here to this one, and we can write bucks. And if it were me, I would highlight this too, so it would just remind me, because you're going to have to know how to graph these lines by yourself. And I'm teaching you an acronym that takes the thought process away. It allows you to rely on the acronym to graph it, and you don't have to necessarily, you don't have to actually know the procedure. It just becomes like muscle memory. All right, so after you write it, I would definitely explain, that horizontal, I'm going to abbreviate, horizontal lines have a zero slope. Slope is 0. And the equation, we'll come out here and put EQ. The equation is y equals the y-intercept. It's self-explanatory. It's telling you where it's crossing the y-axis. Then I'm going to come over here to bucks. We got vertical lines have an undefined slope. And the equation is x equals the x-intercept. I promise the Hoibucks is going to help, okay? I'm not teaching you some weird thing and you're going to be like, I'm never going to use that. You actually will for this stuff. Okay, so let's pretend like the line wasn't graphed for us. Let's confirm where it is. We're reflecting over the line y equals 1. This is what we're reflecting over. This is random, okay? This is random. They're just randomly saying, hey, flip over y equals 1, which means there's no formula. You're going to have to actually map it and count it, all right? When it's random, that means there is no formula or no rule. Let me write rule. There is no rule, okay? There's no rule at all, and it's because it's random. So I would, if I had a blank graph, I would have to graph y equals 1. So I'd look at it and I'd say to myself, Hoibucks. Okay, I see a y, so it's hoi. Hoi means it's a horizontal line. You do have to know which direction horizontal runs. Please remember the horizon is that line that runs left and right. When you look out at the sea, you know, at the ocean. So you do have, that part you have to memorize. I can't help you with that part. But I'd look at it and I'd see a y, I'd think hoi, I'd hear h, horizontal. I'm going to go to the y-axis. I'm going to draw a horizontal line at 1. Here's the y-axis. Here's 1. And then I would draw my horizontal line. There we go. I draw my horizontal line. Now, as you practiced on Thursday, you may like using a highlighter here instead of putting a dotted line. It's up to you. Now that you have your placement of your line of reflection, now we're going to reflect by simply counting. Okay? We're counting. How far is B from our line of reflection? 2 away, so I'm going to count 2 past it. And that would land B prime right here. See that? Yep. So B would become B prime at 2, negative 1. Now we're going to count A. A is, be careful, 1, 2, 3, 4, 5 away from my line of reflection. So I'm going to count 5 past. 1, 2, 3, 4, 5. And that's A prime. 2, negative 4. Then some people count the third point. Other people just look at it because they know, okay, I got it. They remember it's the same shape, same size, it just reflected. So some people can recognize that the rest of the triangle is going to land right here, and they can do it without actually counting it. If you need to count it, by all means count it. But remember what you're doing. It is a reflection, so you definitely don't want to put the rest of the triangle here, because that would be a translation. It's not a translation, it's a reflection. So C prime is 3, negative 4. All right, slide to the right. Let's do the example where we're graphing over a random vertical line. It is random. Again, that means there's no rule. So we are graphing over the line x equals negative 2. This is random, which means there is no rule. You cannot apply a rule here. You're going to have to actually map it out and count it. I would read this and say to myself, I see x equals -2. I would think VUX. That stands for vertical line. I'm going to drop a vertical on the x-axis at -2. So I'm going to go to the x-axis. I'm going to find -2. There it is. And I'm going to drop a vertical. There's my line of reflection. Now it's a matter of counting how far the shape is from my line of reflection and counting past it. So E is 2 away, so 2 past. D is 4 away, so 4 past. C, 5 away, so 5 past. Here. A is 3 away, 3, so 3 past. And then you can see the rest of the shape closes off right there, B prime. And you do need to practice reading the coordinate points. I would love for you to read those points and label them without looking up here and just copying it down. So I'm going to give you a second to do that, and then I'll write the answers. Label those points. B prime, did you get -7.5? Are there any questions on reflecting over a random horizontal or vertical line? The hardest part is graphing the line, but WORKSHEET is supposed to help you with that. Now there's one reflection left, and I actually want to go ahead and do it because there's a rule, there's a written rule. It looks weird, but I would find it to be the easiest one because there's no counting. You just apply the rule, and then you graph it. So if you would turn the page. We are going to reflect over the line y equals x. Notice that this is a specific equation of a line. This is not random like y equals 4, x equals -1, y equals 6. This is saying y equals x, like there's no numbers involved at all. The equation of the line y equals x runs right here where this red is on mine. If you want to take your highlighter and highlight it, that would help. The way this line comes about, and I would not recommend you to plot these points, just watch me as I do it. Y equals x means that whatever x is, y is the same. So don't write all of this. So for instance, if x is 1, y is 1. If x is 2, y is 2. So you'll notice that it's like a stair step. You got 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and then it goes in reverse to the negatives. Negative 5, negative 5. So it's like a stair step, but it runs in a positive direction, okay? Do you have to memorize where y equals x is? It'd be good if you could, yeah. It would make life easier, because if you accidentally said it would say over here, like this, and then you graphed that and it landed like that, I don't even know how to do it quickly without messing up, then your answer's wrong because you just reflected over the wrong line. So it is good to know where it is so that when you finish answering the question, you could say, like, checkpoint, did I do this right? If I know for a fact that y equals x runs in this direction, I know that this picture is going to reflect over here. You see what I mean? Think of folding the paper diagonally. Wet ink, leaving a mark, right? So it's helpful to know where it is. Now, what about the formula? Let me show you this. There's a trick. We are reflecting over the line y equals x. Oh, I didn't mean to highlight that part. Here's the written rule. Can you tell me what happened? They swapped positions. You notice that? X moved to the y position, y moved to the x position. I'm going to show you a trick. It's a corny little trick that you will draw on y equals x, the equation, and it will help you remember the formula. You with me? Everybody with me? Hello. Okay, if I tell you reflect over the line y equals x, that means y becomes x and x becomes y, which will help me remember to take the points and just split them. Okay? If you'll draw these arrows, I promise it's going to help you remember to just take the coordinate numbers and flip them. All right? Now, in the past, we've been able to graph it and then read the points. You can't do that here. You're going to have to actually flip them, write the points, then graph it. So what would A prime become? 3, negative 2. What would B prime become? Yep. And C prime? Yep. Now I'm going to graph it. So remember, be careful. The coordinate points. The first one's right or left. The second one's up or down. I'm going to go right 3 down 2. Right 5 down 2. Right 3 down 6. Now you might be thinking, now this doesn't look like the same size as what started as it, but mine's a little distorted because it's going through 3 screens to get there. Notice how I can visualize if I folded the paper along that diagonal, those pictures should match up. Now, if I said, write the rule for the equation, or if I said, write the rule for reflecting over y equals x, this is what you would write. This right here is the rule. You would write y comma x, okay? Now, what I want to do is move to practice. I want to do it a little different first. I want to practice graphing the random horizontal and vertical lines before we dive right into reflecting. Because if you're graphing those lines wrong, all your reflections are wrong. Okay? Open up your Chromebook. I'm going to send you an iExcel link. We don't have an iExcel subscription, but we can take advantage of iExcel's daily free questions where we can practice up to 14 questions, I think. You're going to see how quickly this goes.
So in Google Classroom, if you click this link right here, it's going to give you an iExcel page. It's going to ask you to log in. Just close that little pop-up window. You don't have a login. We're going to take advantage of the free questions that it gives you each day. It says graph y equals 1. You should think to yourself, hoi vux. I see a y, so I'm going to think hoi. That means I need to go to the y-axis, find 1. That's right here, right? And am I drawing horizontal or vertical? Hoi, horizontal. So you're going to click a point on that y-axis at 1, and then it's going to give you, it's going to say like, all right, where do you want your other point? Well, if I want horizontal, then I just need to come out beside it, right? It needs to be horizontal. It doesn't matter where you click the second point. As long as it's not slanted or vertical, that would be wrong. So I'm just going to go right there. It's going to say, yay, good job. All right, y equals -6 for me. I'm going to go to the y-axis. I'm going to find -6. It's horizontal because it's hoi. X equals 5. I'm going to go to the x-axis, find 5. It's vux, so it's vertical.
By now you should start to get it. I would love to see you get a SMART score. I think you can get up to maybe, let me keep doing mine.
It's going to stop you at some point. It's going to say that's enough for your free practice. Y-axis. Yeah, I want to walk by and look at it. So don't, when it says you're done, don't change your screen. Let me come look at it. 10? Okay. I don't know where I got 14. Yeah, okay.
So you should be able to get a SMART score near 68. You might get a few wrong. Are you in Google Classroom? Yeah. Oh. Okay. It's all right. Gotcha. Do we need to show you how to do it? Yeah, I want to walk around and look at it. After you show me you did it, I'm going to give you 35, which is the practice. Now this is only reflecting over the random horizontal and vertical. It does not have the y equals x one. That's on 36, which is your quiz review. So show me your screen. This practice paper that I'm giving you is practicing reflecting over these random lines. This is page 35. If it were me, I would write hoi vux up here at the top to remind you when to draw what direction. When you get down to numbers 5 and 6, be careful. These are combo transformations, meaning you should have 3 shapes here when you're done. 3. You got the one you start with, the pre-image. We're going to reflect first, the way it tells us to. This says reflect over y equals -3. So that would be hoi, right? Which means I'm drawing a, what direction? Horizontal line. So I'm going to go, watch how I do this. I'm going to go to the y-axis. I'm going to find -3, and I'm going to draw a horizontal. There's -3. Horizontal would look like this. So this one is actually sitting on the line of reflection, which means some of these points don't move. Any points that are on the line of reflection, they don't move. So C prime and S prime would land right there where they started. And then Y prime would be here. R prime here. And now I've got my graph. What is this letter? S. S prime. And now, after you reflect, it's a domino problem. You're going to take your new shape and you're going to translate what is the rule? What direction am I going? I'm going right 2 and then I'm staying put. So I'm going to take this and I'm going to go right 2, which means this is going to look really ugly, but it's okay. I'm actually going to switch colors so you can tell that I am actually doing the work here. It's hard to tell. Come on. Alright. So Y prime right 2 would land here. This would be Y double prime. R prime right 2, wait a minute, would be here. S prime would be here. Double prime. C double prime would be here. Please don't let the mess that's staying on top of itself start to confuse you. I've got to do this.
I did it, but I closed my Chromebook and it did flash on me, but it says in the
Oh, okay. Okay.
I promise I did it.
Okay. Well, I know you did it because it's telling you you're at your limit.